Welcome everyone to this IGLUNA virtual campaign. So as usual, we have every day an expert from the space sector presenting. So today we'd like to welcome Sylvain Chaty. He's an astrophysicist and professor at the University of Paris, and he wrote a book about the colonization of space. So today Sylvain Chaty is going to discuss the core problematic of IGLUNA. So yes, we are building technologies to sustain life on other places than Earth. But what does that mean? Where would we go? And is there a human-friendly place somewhere in the universe? So we are very looking forward to Sylvain's presentation, where he will provide us with useful background information to understand the feasibility and challenging of going, living, and staying on other celestial bodies. So as usual, if you have any questions, feel free to use the chat, and we will have time at the end to discuss and exchange with Sylvain. Thank you.
Thank you very much, Eva. Okay, so thank you very much also IGLUNA, the virtual field campaign, for allowing me to speak about this field, which for me is very interesting. This is a part of something I'm teaching at the University of Paris for many years now. And it's a field which is evolving very quickly, so it's very interesting to see how it evolves and what nice discoveries are made nearly every day. So yeah, I'm very glad to be here to speak about this. So I speak about the colonization of space, and we'll see what it means and why this is so important for humanity to see what there is outside Earth and what we can do to go there and to try to live there. And so I decided to speak about different things around colonization of space. And so as Eva said, I just wrote a book on Colonisation de l'espace in French. So it's a book which, in fact, begins with the colonization of Earth by life, and then see what are the possibilities of colonizing other places in the universe. Like first the moon, of course, the solar system, and then we go further with the planets. And also there is some, I write a bit on the debate about colonizing other planets and the ethical questions about this and things like this. So it's a very illustrated book that I find very nice, and which is quite funny, is that it went out exactly during the confinement period. So it was strange to be always at home when while some journalists were interviewing me about going out of Earth and going to space. So I will split this presentation in 4 parts. First, very briefly, I will speak about the context, why we speak about this. In fact, why today at this time we speak about colonization of space. Then I will see the possibilities of colonizing the solar system. And then we'll go further with colonizing the exoplanets. And I will finish with a question that Enrico Fermi had asked a few decades ago, which is, where are they? Which means, where are the extraterrestrials? Which in fact is related to this question, because if we want to colonize space, it also suggests that some other life in the universe have wanted to colonize space. Okay, so first part, the context. All the illustrations are taken. I mean, for these, the titles are taken from my book. So, colonization of space, part 1, the context. I just wanted to begin with the fact that this is a subject that we speak about that was spoken about for, I would say, hundreds of years, or even more, thousands of years. And some astrophysicists, like, well, astronomers, I would say at this time, like John S. Kepler, wrote a book called Somnium, where he could imagine someone going to the moon, an Icelandic boy going to the moon. And then there is this tale by Savinien Cyrano de Bergerac in the 60s, who wrote a book about entitled The Other Worlds, Empires of the Moon. And then there was a second part where he was going to the sun. And what is, well, there are some funny parts, for instance, how to go there. You see on this picture, how he managed to go to the moon. He's within something which, in fact, does some fireworks, and he goes like this to the moon. So it looks very funny now, but in fact, what is also interesting that it looks a bit like we went to the moon with Saturn V. And there, when he arrives to the moon, he finds something which first looks like the paradise. And then, in fact, when he is on the moon, the people on the moon looks at him very strangely, well, like, in fact, as a stranger. And they don't like him. And so they put him in jail, and in fact, he has a life which is very harsh. And so it's a philosophical tale about looking at stranger people, at people that you don't know. And it is very interesting in the context of if we find some life outside of Earth. And the same happens to him when he goes to the sun. And in fact, he has also some misadventures on Earth. So it's everywhere there are strangers. And the other tale I wanted to speak about was the very famous Jules Verne tale From Earth to Moon, which is 2 centuries later. And then you see this bombs that are sent to the moon. So of course we can't imagine people inside these bombs surviving to this launch. But so they go to the moon. And what is interesting, this tale that Jules Verne describes very precisely what equipment they have to bring there to go to the moon, to survive in the moon, and to explore the moon. So of course now we don't plan to go to the moon either way. But it's interesting to see that people have always imagined to go to the moon. I mean, probably because it's very close to us, it's very bright, so we want to go there. So I want first to take a step back, and before speaking about colonization of other worlds in the universe, speaking about how has life colonized Earth. And you see here the Petit Prince, who is on his planet. And obviously, this is not a planet where there would be life. You see, there is no atmosphere, there is no water. So in fact, what do you need? The only thing that Petit Prince has here is a rocky planet. So what do you need to colonize a planet, or what was on Earth to allow life to colonize it? Well, first, like the planet of the Petit Prince, it was a rocky planet. It is a rocky planet. Also, there is an atmosphere, which allows many things to breathe, of course, but also to avoid big gradients of temperature, as we will see later. Of course, there is liquid water, and this is very important, not just for us or for the living beings on Earth to live, to breathe, to have some water to live. It's also because molecules assemble easily in a liquid form, more easily than if it's gaseous or solid. Then the temperature on Earth is between 0 to 40 degrees. And you'll see that this is important for water to be liquid, and also not to be too hot, because if it's too hot, the molecules are destroyed. Then there are other things that we are not sure if these things are very important for life to be present on the planet, or for life to colonize the planet, Earth has a magnetic field which is quite strong, which allows to make a shield, magnetic shield, to protect against the stellar wind, and more precisely against the solar wind, which are very energized particles which arrive on Earth and, well, can cause cancers and genetic mutations. So it's useful to have this magnetic field. And this is created by a rotating core inside the Earth. And the last thing, that the Earth has a moon, which is a big satellite. And this satellite, as we can see from the Earth with just binoculars, we see that the moon has many craters. And the craters that the moon has is craters that the Earth didn't have, because many asteroids who passed close to the moon crashed on the moon. But without the moon, they could have crashed on Earth. So it's useful to have this big satellite. We don't know if without any big satellite, the Earth would not be colonized. But with a big satellite, it's easier because you shield from meteorites. And also the other advantage that you have some tides, periodic tides, and this could help also for us to, for life, sorry, to colonize Earth, to develop and colonize Earth. So how has life colonized Earth? Where we see there are many ingredients, and one of the ingredients which is in fact visible from outer Earth, from space, and from very far from Earth, is this blue color, which in fact is, of course, due to water. And I always ask to my students, is there water on Earth? Is there water on Earth? Well, of course, there is water on Earth, but is there a lot of water on Earth? Of course, there is water everywhere. We see it's blue. The Earth is blue, so there is water everywhere. But do you think there is really a lot of water on Earth? And when you take all this liquid water, which is in the oceans, when you take the water which is in the atmosphere, you take everything and you compare it to the size of Earth, and in fact, there is not a lot of water. Of course, there is also water inside Earth. But the water which is accessible to the living beings on Earth, and which allows life to appear on Earth, there is not much water. So, which means that we have to protect this water. In fact, the Earth is a very fragile system, as we know. But this image, I think, is one of my favorite because it shows really that there is not a lot of water on Earth, and you have to take care of water on Earth, and of Earth also. So then the question is, well, because we want to speak about colonization of space, I'm here for this. But the question here is, why should we live? Why should we live? Well, we might want to live because we want to explore other worlds. We have always done this. Neanderthals, Homo sapiens have always migrated, discovered other things, perhaps because they wanted some more food, perhaps they wanted more water, perhaps they wanted just to see what there was beyond this point. So we want to explore, and we will see that we have already explored a big part of the solar system. And we are exploring also the rest of the universe, of course, not going there physically, but we send probes and we also observe them with telescopes and satellites to discover many things. So we might want to live just because of this, just to discover some other things, like Colomb discovered the America, and Magellan made the tour of the world. We could just want to try to discover some more things. There are other reasons that are not probably so, that are more pragmatic, I would say. For instance, the loss of biodiversity. Well, you see these emperor penguins there, which have It's not the most endangered species, but there are many species that disappear today, and we speak about the sixth extinction, like loss of biodiversity. And this might be a problem for human beings also. So this might be a reason for Earth, for people to try to go to another place. There are, of course, reasons that are related to climate change, pollution, and things like this, which of course all are related also to loss of biodiversity. The other reason that we know too much now is the possible pandemic, like this one we are living now. But let's think about the what we call the Spanish influenza, which killed at least 50 million people on Earth. While we might think that this could be a cause of at least a few people not infected leaving Earth to protect or to preserve some parts of the life on Earth. Well, these are causes coming from Earth, but there are causes that might come from outside of Earth, which might put us on a trip outside of Earth. Is exogenous cause, like for instance an asteroid, a big asteroid coming to Earth. So remember the 10-kilometer size asteroid which collided Earth 65 million years ago, and which destroyed nearly 75% of all life on Earth, animal life and vegetal life. So this is always possible. Statistically, there is one chance every 65 million years to such an asteroid to collide with Earth. So it might. Of course, we have the ways now to see these asteroids coming, but we don't have yet the ways to avoid them. So we can try to deviate their trajectory, but of course we have to know well in advance that they are coming, and even the calculations to know exactly where they are coming and where they are passing, if they are going towards Earth and passing near Earth. These calculations are complicated. Okay, so imagine we have to leave. If we have to leave, where are we going? Well, we have to look for Earth 2.0. Don't really like this name of Earth 2.0, but put it like this: we want to find another Earth which is nearly as good as the Earth. So this diagram shows you different stars with different brightness, and you have the solar system there, from Mercury to Neptune, let's say. And you see there is this colored band in the middle that shows what we call the habitable zone. This habitable zone, you see, there is nearly only the Earth inside. And the habitable zone means that you have a planet, rocky planet with an atmosphere, and there the temperature can be between 0 and 40 degrees. So only the Earth is inside. Venus and Mars are at the limit of the habitable zone. So looking at this diagram already, you can say, well, there is no Earth 2.0. There is Earth 1.0. There is, in the solar system, no other place like Earth. Okay. Presentation is finished. Well, not really, because we can look at other places in the solar system where we could try to find some other places which would be good for us or for life to adapt, to develop. So habitability zone, I said it's a rocky planet with an atmosphere, temperature between 0 and 40 degrees. You have some liquid water, but you have a very fragile balance between greenhouse effects, like what happened on Venus, we'll see it, and also divergent glaciation, which is something similar that happened to Mars. And the Earth has also a very fragile balance. And on Earth already, there have been some periods where we call this snowball period, where the ice was surrounding all of Earth. So this can happen on Earth also. We can have a climate change, and with a greenhouse effect, which is diverging, and we can have also an ice ball around all Earth, which is also diverging. So when we will speak about other planets in other stellar systems, we'll see that this habitability zone changes and is closer to the star when the star is cool, and it's further away to the star when it's hot. That's because to have this temperature of between 0 and 40 degrees, you have to be closer when the star is cool, and you have to be further away when the star is hot. So it depends of the temperature of the star, so on the nature of the star. Okay, this is nearly what I wanted to say about the context before going to the, I would say, colonization of space. And before I go to the next chapter, I wanted to do a small quiz, and I will make like this 4 quiz at the one each at each end of each part. And the quiz number one is what is this? So I will let you think about this for 10 seconds. I don't know if you could recognize exactly what it is. It has a round shape. It looks like there are some black parts which look like craters on it. Yeah, it could look like the moon. It is the moon, but it's not the part that you are used to see in the sky. In fact, it's the dark side of the moon. It's the first image of the dark side of the moon, which was taken by a Soviet Luna 3 probe, 7th of October 1959, so 10 years before the Americans went to the moon. So congratulations for the people who guessed it. So let me go now to the second part, which is the colonization of colonizing the solar system. At least asking the question if whether the solar system can be colonized and where. First, well, let me remind you if this is needed, the solar system. So you have this sun, which is very big. Then you have 4 small planets, which are called telluric planets because they are rocky planets, Mercury, Venus, Earth, and Mars. Then you have this small asteroid belt, and then you have the 4 giant planets, which are gaseous planets, Jupiter, Saturn, Uranus, Neptune. And then you have the Kuiper asteroid belt, and then much further away you have what we call the Oort clouds, where you have the comets, or at least the core of the comets, and like the comet we see now, the Neowise, which is very nice in the sky. And well, I first said that you remember I said for a planet to be colonized better if it's a rocky planet, and so it's not the case of Jupiter, Saturn, or Neptune. So I will not speak about this gaseous planet. I will just focus here about the telluric planets, which of course already focuses a bit subject by nature. And I will speak also about one satellite of Saturn. Okay, first, the most obvious is, can we colonize the moon? This is the moon shown in false colors, as you don't see it because normally you see it very white. This is when you, when in fact it's seen as less bright, you can see these colors that appears on the moon, but you don't see that with the eye. Well, there are many plans to go to the moon. I will not describe all the plans, but I could just say, for instance, that NASA just awarded a $200 million contract to Astrobotic Technology. The plan to send a lander to carry the first rover to be sent to the moon surface. The first rover after the one from 1972. So in 2023, which means that nearly for 50 years, there will not be any return on the moon. And the plan, of course, is to, well, in this case, to search for ice that could supply water for astronauts. And the plan later is to send some astronauts on the moon. Let's go with this. Now, there are some rovers on the moon, like, for instance, the Chang'e 4, Chinese one, which is on the dark side. And so this was a challenging landing to land on the dark side, because when the probe is on the dark side, you cannot communicate with Earth. So you have to send another probe, which is orbiting Moon, and you communicate with this second probe, and the second probe communicate with the lander, and they successfully landed on the moon. But they didn't send anybody yet. So the plan, when you speak about colonizing, of course, we don't speak only about robots, but we speak also about people. So there is this Artemis plan, which is American plan with European collaboration to send people and robots on the moon in 2024. I think this date will slip a bit. So there is this SLS launcher, and then the idea is to build a gateway station which would be close orbiting the moon, and you would have an Orion module which has an European collaboration, and this Orion module would go from the Earth to this gateway station. And in this case, you can begin to send material, robots, and also people on the moon. Of course, it will never become Earth 2.0. There is no atmosphere on Moon, but the aim in a middle or long term would be to build a moon village, which is something that was a term that was invented, I could say, by the ESA director in 2015, I think. And the aim was to install a permanent human robotic presence on the moon. And the moon has many resources, because if you go to the crater which is close to the southern pole, then you have some water, solid water, some ice inside the craters. And so you can use this water, of course, to make some air to breathe, but you can also use it as water. You can use the regolith, which is the dust of the moon, which is created by all the asteroids falling to the moon. You could use this regolith to build some domes on the moon. This is what you see on this artistic view. And you can also use the helium-3, which is on the moon, as a fuel. Of course, so you can live there. You see all the people there on this artistic view have they are like astronauts on the moon. You cannot walk like this without having something to breathe. So they have all what is needed to breathe when they walk on the moon. The idea probably is not to bring many people, but the idea would be probably to be like a spaceport to go to the solar system. And you can go to the moon, and you can launch some rockets from the moon, which has less gravity, so it's easier to launch from the moon than from Earth. And then you can go to the solar system and explore the solar system. So the moon is an interesting place. As I said, it's not the Earth 2.0, but it's a good starting point to begin to colonize the very close universe, very close to Earth. Speaking about the moon, there is a planet which is very similar to the moon. I just, before I go to the planet, just want to mention that on the moon, its temperature is between nearly 150 degrees during the day and nearly minus 100 degrees during the night. Be prepared to a big temperature gradients. But there is even worse in the solar system. For instance, with Mercury, which is the planet I'm showing now. Mercury is very craterized like the Moon because there is no atmosphere, so there is no erosion. So when you make a crater there, the crater will stay forever, which is not the case on Earth. I show you Mercury in full colors so that you see that there are differences in the terrains on Mercury. And on Mercury, the temperature gradient is even worse than on the Moon because it's between minus 150 and plus 450 degrees. So there you have very strong temperature gradients. Probably it's hard to survive on Mercury, even with protective dressing. You have, like in the Moon, you have in the craters which are close to the North Pole or to the South Pole, you have some ice, water ice. So you could do the same than on the Moon. You could exploit the ice, the water, which is in the soil of Mercury. Problem is the high temperature. There is a very tiny atmosphere on Mercury. Probably because of this high temperature, it's not the best place to even to have a spaceport on Mercury. Okay, so forget Mercury. Let's go to the next one, which is Venus. Venus, the goddess of love, has clouds which are very thick, so thick that in the 1960s, people thought that there was a luxuriant, gorgeous vegetation, like a bit like in the tropics on Earth. When you send a probe which can use radar to look through the clouds, you can see that Venus is not exactly like this, like paradise. And this is another probe. So this is the Magellan probe who made these images. And what you can see that the landscape looks a bit desolate with some volcanoes there and even some basaltic lava. So it's very desolate. Temperature is of plus 470 degrees. It's hot. It's not the worst. The worst is that you have a pressure of 90 times the pressure you have on Earth. And also you have some rains of sulfuric acid. So I don't know if it's the goddess of love, but it's a passion which is very dangerous. So probably the Venus will be hard to colonize, except if we try to terraforming Venus. We'll speak about this later, but it will not be easy. Okay, so the next Earth, you know already. So the next planet in the solar system is Mars. Colonizing Mars. Mars is in some way very similar to Earth, nearly the same size, a bit smaller than Earth. Gravity is 38% of Earth. Same duration of the day on Mars, the same seasons. So you would not be too, you wouldn't feel too strange on Mars. In 1666, Cassini discovers polar ice caps on Mars, so which means that there is some water ice, and this has been imaged then much later, with the Mars Express probe, for instance. You have here the ice caps on Mars. Then you have this very nice story that I have to say very quickly, but in 1877, Giovanni Schiaparelli saw some what he called canali, which in Italian means a structure which looks linear, but it's not. It can be natural structure. So he made a map of this Mars. But then there is this very rich and passionate American businessman, Percival Lowell, who saw also these what he called channels, but in his head it was more like artificial channels, and he thought these were channels to take some water from the polar ice caps and to bring it to all the cities that there are on Mars. So you have this very nice map of Mars with the irrigation channels, and well, even he was even invited by the Nature editor in 1907 to speak about what was the status of the Martian life at this time. So at this time, we really think, at least some people really thought that there could be some life on Earth, and probably this allowed to begin the myth of the Martian that, in fact, still stands today. We still want to find some life on Mars. Temperature on Mars is between minus 100 degrees to plus 0 degrees. So on the 21st of June, on Mars at midday, you have 0 degrees, which is in fact not bad. It's probably something similar to Antarctic. But it's better than what you have on Mercury or on Venus, for instance. Which explains why, all of this explains why there have been many missions on Mars. The first one, American mission, Viking 2, 1976, landed on Mars, looked for Martians, didn't see any people walking on Mars, but they did see some frost, which means that there is water on the surface of Mars. They saw also that the rocks were covered with dust. They saw they could analyze the composition of Mars, which is very similar to the composition of the crust on Earth. So either from volcanic or from sedimentary origin. They could show that there was some presence of water on the Martian soil, and now with all the probes we sent to Mars, we confirm that there is water everywhere on the Martian soil. But the Viking already made an experiment that they showed that there was no organic molecules, no life. So organic molecules, molecules with carbon and hydrogen in the molecule. So at least for a few centimeters below the surface, there was no life. Perhaps there is life below this, but not on the surface, and not for a few centimeters below the surface. And already at this time, they were very careful not to bring bacteria from Earth to Mars. And this is a picture taken in 1975 with the Mars Viking lander, which is sterilized in an oven at a high temperature, something we don't do now at such high temperature. And there is always try to sterilize the probes, not to bring bacteria from Earth to Mars, because obviously, if you bring bacteria on Mars, and if there is some life on Mars, then you destroy all the life that there is on Mars. And it would be a pity, because it would be nice to see if life has appeared in some other place than Earth, and to see how it developed, if it appeared. So, just show a few images of some probes, like Mars Express, for instance. You show this picture around, you see a bed of a river, and you see in the blue parts, this suggests the presence of ice. It shows the presence of ice, sulfates, and also some clays. And who says clays says water, which means that there was a lot of water, liquid water on Mars that was present in the first probably billion of years of the planet Mars. You see also some crater impacts, which are very interesting, because this is something you can see when you throw a stone on a wet sand, and you see that it will make a splash. And in fact, what you see around the crater is that the water that was in the soil of Mars just boiled up, and then came to the surface. So you see this splash around the crater, and this shows that there is some ice water in the soil of Mars. Something even more impressive is that we can now see some places which are the fossil of old tsunamis on Mars. This is the trace of a giant tsunami which was created by an impact on Mars between probably there is 3 to 3.5 gigayear, with a wave of 300 meters high, breaking at 220 kilometers over a distance of 1,200 kilometers. And here you see a model of this tsunami which is evolving. So this is very impressive. And now there is a probe, an American probe, which is called Curiosity. This is a selfie taken by Curiosity. It's a mosaic selfie taken by Curiosity. And this is the path followed by Curiosity. And well, now I will show you a video of Curiosity going to Mars. So now the question that Curiosity, for instance, want to answer is there life on Mars? And there is a polemic with methane, because the methane was detected on Mars. And in fact, if it's detected, it means that there is some source of methane, which can be either volcanoes, so geological source, or bacteria, so biological source. And there is a European probe, which is a trace gas orbiter, which is now trying to answer. So this would be interesting to see if there are bacteria now on Mars. But what happened on Mars? Why was there so much water? Now there is no water left. Well, what do we think is that the atmosphere on Mars just disappeared. Like since 3.6 gigayears, the atmosphere disappeared, and then the water on Mars disappeared. And this shows that the environment can be very fragile, as it can be on Earth. And so this is the summary of what you have on Mars. With you have also some regolith on Mars, like on the Moon. You have some strong wind on Mars, and you can have some perhaps you have some water in the soil, and perhaps some life, we don't know, in the subsoil of Mars. So there are many missions that are planning to study this planet. For instance, there is this ExoMars, European and Russian mission in 2022, which will look at which will drill the soil of Mars for 2 meters. And then there is this Mars 2020 American mission, which will also take some samples of Mars. Mars is very studied, and we saw that it's very close to Earth, and this is why people have imagined terraforming Mars. So what is terraforming? It means that you can try to change the atmosphere, and at least locally, like you would see here, to build some small cities where you could breathe like this without just you go out and you breathe like this. Of course, there are some questions, because how do you protect from the asteroids, for instance, which could break this protection, the shield protection around these cities? This we don't know. For Mars, we would have to put some, probably some methane, for instance, to increase the temperature of the atmosphere. Okay, so for the theoretic planet, it's all. We don't have more planetary planets, but we have something interesting in the solar system, which is Titan. Titan is the satellite of Saturn. This is the view from Earth, so you don't see much. This is the view from Voyager. You see some atmosphere. And this is the view from Cassini, which is a probe, American and European collaboration probe, which went to Saturn, took some pictures of the Titan. Titan is the satellite of Saturn, which is quite big, 5,000 kilometers diameter, and the only one with an atmosphere. And there are some oceans of liquid methane. So if you like swimming in liquid methane at minus 180 degrees, Titan is for you. You have some clouds of methane also. And well, there is a probe, Huygens, which plunged into the atmosphere of Titan, and which survived in the environment of Titan with very cold temperature. And here you see a few pictures that the probe took when it was approaching the soil of Titan. With you see here an island in a great lake on the surface of Titan. And here you see it is approaching something which looks like a landscape around the sea on Earth. And there you see a few hills there. And there you arrive on Titan. This is a picture of the landing site. So as I said, the temperature is very low, but you see there are some stones that have a round shape, and this shows that there are some tides. So there is some liquid on Titan, but it's liquid methane, it's not liquid water. You are at minus 180 degrees. And under the soil of Titan, you have some ocean of liquid water this time. So you could imagine that there could be some life below the surface of Titan. So it's a very interesting satellite, which will be explored by a Dragonfly mission probably in 2034, so in a long time. So a drone which will go to Titan. Okay, in the solar system, there are also comets like Halley, Churyumov-Gerasimenko, Oumuamua, the Neowise that we are seeing now. This, we will not colonize this, but we could exploit the resources of these celestial bodies, like to do some interplanetary trips, for instance. And this allows me to arrive to the second question. What is this? And so I leave you for 10 seconds to think about this. This is a small bright dot in the middle of something which looks like dust. And in fact, this is the pale blue dot taken by Voyager 1 in 1990s, where you see, in fact, the Earth. And around the Earth, you see this dust, which is coming, in fact, which is the origin of the planets. Planets have been made of dust, which is visible here. Okay, so this brings me to the part 3, colonizing the exoplanets. Exoplanets, well, they are hard to detect because the star is always much brighter than the planets. It's nearly 1 billion times brighter. Well, I cannot avoid mentioning here the discovery in September 1995 by Mayer and Kellos, who won the Swiss astrophysicist who won the Nobel Prize last year for the discovery of the exoplanets, the first extrasolar planet, 51 Peg-b, which was like a Jupiter planet very close to the star. Now we know 4,282 exoplanets, so it's a lot of exoplanets, but obviously not all of them look like Earth. And on this diagram, you see that we found some what we call the hot Jupiters. We are planets like Jupiter, massive but very close to the star. We discover also some Jupiter's planets, some hot Neptunes, and also some super hot Earth, which are so nearly to 10 times the mass of the Earth and nearly closer to the star. And what we want there is to find an habitable exoplanet. So this is the diagram I showed earlier, where there is also another planet, Gliese 581, and you see that when the star is colder, you have to be closer to the star. And we know now some planets which could be potentially habitable, and there is one here on the left, which is called Proxima Centauri-b, that I will now describe briefly. Okay. So it's a closest star at 4 light years, so it means 40,000 billion kilometers. It's a triple system, but you see here Proxima b, the planets, which has an orbital period of 11 days, so very close to the star. And the question is it habitable? It's the closest of Earth, but is it habitable? Well, we don't know. And in fact, you see on this diagram, you have the radius versus the mass, that depending on the observations, depending on the models that we put there on the observations, the planet is either rocky or it's an ocean planet. We don't know exactly what is the real nature of the planet. So what do? Do we go there? It would take 70,000 years to go there. So I don't want to go there. But there is a project now, which is called Breakthrough Starshot, which is sending probes to Proxima Centauri at a velocity of 20% the speed of light, which means 20 years of travel. At this velocity, you reach Neptune in a few days. And you send thousands of probes of weighing nearly 1 gram with camera, navigation, communication, equipped with a nearly 1 gram solar sail powered by a 100 gigawatt laser, and you arrive on Proxima in 20 years. Then you send back the picture, which comes back in 4 years. In 24 years, you know if it's a rocky planet like Mercury or an ocean planet. And you see if it's worth going there and spending 70,000 years to go there. There are other planets like this. For instance, this TRAPPIST system, which it's a very cold star, but it looks like the planets could be habitable. And you have even some artistic view of people going to this system and discovering this one of these planets. So it's the planet Hop, and you have the hub zone vacation, voted best hub zone vacation. So we can dream, of course. So we don't go to these exoplanets now. We cannot send probes there, it's too far away, but we can observe them. And the two future best ways to observe them is the James Webb Space Telescope from the NASA, which would be launched next year, normally, and the European Extremely Large Telescope, which first light could arrive in a few years. And the aims are to analyze the composition of the atmosphere of these habitable planets and to see if really they are habitable. And this brings me to the third quiz. What is this? And then I will show you a video, and at the end you tell me what it is. So this was, in fact, not Mars, but it was a view of the Atacama Desert taken by a friend, Serge Brunier, with conditions very similar to what you have in Mars. Very briefly, I will now answer to the question, where are they? Well, I will not answer to this question, but I will ask the question. Where are they? You know that we are, if we want to colonize space, then we are not the only one to colonize it. If there is another civilization, and of course, we have already given signs of our presence. For instance, we sent a probe like Pioneer 10, where we have sent a map of where we are. So if extraterrestrials want to find us, they can find us. And then there is this direct equation, which when you take all the consideration about number of stars that have planets, number of habitable planets, number of planets where life emerges, etc., you arrive at nearly one planet on which there is life capable of broadcasting, capable of sending signals. So if this is the case, if we are the only one, then it's strange. And it's very strange, but the answer could be that there could be many civilizations, but each intelligent civilization lives only for a short time. And at some simultaneous time, we are the only one. And so this is the Fermi paradox. Where are they? We don't know, but perhaps there are not any other. We have not found any other civilization yet, but it's like diving into an ocean and after finding empty, you say there is no fish in the ocean. So I will finish with the last quiz, which is what is this? Probably you know it now. This is a geoglyph looking what it is called the astronaut in Nazca, Peru. And I will finish with I will not finish with this. I will finish with this slide, which is my favorite, which is the Apollo 8 first extraterrestrial vision of Earth. And the astronauts said, we went to discover the moon, and we have discovered Earth. Thank you very much.
Thank you, Sylvain. That was really interesting and very dense. So we have many questions going in many directions. So I will take some of them. First, you talked about terraforming other planets. We were wondering about the ethics behind it.
Me too. Yeah, I think if there is some life on a planet, my point of view would be not to go there. If there is no life on a planet, my point of view would be, are we really sure there is no life on the planet? And if we are sure, then I would try to make less harm as possible on the planet. I'm not really in favor of terraforming.
Yeah, speaking of life, what is considered as sign of life? What are the conditions to be considered as life?
Well, life, you have different definitions, but one of the definitions is that it's an open system which exchanges energy with the exterior, and also it's a system that evolves like in the Darwinian sense, in the sense of evolution. So for instance, a virus, there is a polemic on this, but a priori, a virus is not a living system because it needs something to be in to live.
Another question regarding life, can life be possible even if they are affected by a strong radiation dose? With a lower atmosphere density on Mars and the Moon, do you think life is possible on other celestial bodies?
Yeah, this is a very good question, and indeed, this is a very big problem. The solar wind is very dangerous, so we don't know what is the effect of the solar wind for a long time, and this is not too much a problem for the Moon, but it is for Mars. because for Mars, for the Moon, you go there in 4 days, and you come back in 4 days. So in a week, nearly you have disappeared. But people disappear for a week, and that's okay. They're on vacation. But for Mars, you leave for 6 months to go there. You stay there for 2 years because you need the Earth to go around the Sun like Mars, and then to go back, you need another 6 months. So nearly 3 years, and you are bombarded of solar wind for 3 years. And this we don't know what is the effect, but probably not very good. So this might be a real limitation of, for the moment, of interplanetary trips.
And what do you think about living on asteroids?
Living on asteroid is not very easy because any small movement that you make, you are ejected from the asteroid. So because the gravity is very small, so you just do this and then you're ejected into space. No. Well, what you can do is, if you want to exploit the resources that you have in the asteroid, this you can do, but I wouldn't say to live on an asteroid. You have to live like this, you know, on the asteroid to grab it always. It's not very fun.
And to avoid the impacts of asteroids on our bigger planets, what do you think of the joint NASA-ESA Hera mission? Do we have technology to deviate asteroids from their trajectory?
Well, at the moment, it's what they are trying to do is to see if they have, if they can do this. Probably on small asteroids, which can do a lot of harm, it might be probably possible. For big asteroids, I think it's probably not possible in the short term. So our best chance is statistics. There are not many big asteroids, so let's hope that there is no big asteroid that will hit us before a long time. And also there is a lot of ocean on Earth, so if it's not too big, it can fall into an ocean. It's not too a problem.
Another question is, what are your thoughts on colonizing and exploring other systems? And on that point, what do you think of the Breakthrough Starshot initiative to Alpha Centauri?
Well, I spoke a bit about the Breakthrough Starshot. It's not a way to colonize the system. It's just the Breakthrough Initiative just to take pictures of Proxima Centauri-b, and that's it. The probe will go there. They go very fast. So they go there in 20 years, they take a picture, they send back the picture, and then they go on. So there is nobody in the probe. It's just a 1 gram probe which goes there, take a picture, and you have the picture in 24 years, which means that if you send it now, in 2044, you have the picture of Proxima Centauri-b. And the probe went at 20% of the velocity of the light. This already shows that it's very far away. And in fact, it also answers the question, is it possible to colonize exoplanet? Now, I think it's not. It's too far away for us. It's already, you see, quite long at this velocity to send some probes, very small probe. So to send human beings there or life there, I think it's still very far away. Let's first concentrate on the solar system, which will be already difficult, as you said, for the solar wind, for instance. And let's also take care of the Earth 1.0.
Maybe one last question. When do you personally think we will get to colonize other celestial bodies? Please being as realistic and sincere as possible.
The question is when?
Yes, when do you think it will happen?
Colonizing, it depends what we think about colonizing. If it's only sending robots on the planet, we already colonized Mars, because we can send robots on Mars, we can send robots on the Moon, so this is done. If it's sending people, we sent people on the Moon already. I think nobody could say that we colonized the Moon. But if you can send 10 people on the Moon, I think it's feasible with all the technological way we have now. We can send 10 people on the Moon. Okay, that will live there. Is this colonized? I don't think this is colonizing the Moon. Colonizing for me means really we live there and we don't think about coming back to Earth. And Sincerely, I would say this is not happening before a long time. And I hope that we will do it because we want to do it, not because we have to do it because the Earth is not in a state where we can live on it.
Yes, one last question. What could be the reason for the disappearance of the atmosphere on Mars?
Well, yeah, sorry, I probably I was a bit quick on this. So we have some observables that the probe, the MAVEN probe, showed that the atmosphere was disappearing on Mars at a rate which was quite high, and probably this has begun very probably 3 billion years ago, and probably this is because Mars doesn't have any or has a very weak magnetic field. So there is no shield against the solar wind. And so the solar wind interacts a lot with the high atmosphere of Mars, which is not the case on Earth. Earth has a very strong magnetic field. So you have this shield, magnetic shield, and the solar wind cannot go directly to Earth. It just avoids Earth. And then some of the particles go to the polar caps, and this creates the aurora that you can see in the sky. But so majority of the atmosphere on Earth is protected because of this magnetic field, which is not the case in Mars.
Okay, great, thank you. So we have to finish now. We are already a bit late. So thank you for this very interesting presentation. And we hope that our viewers are now able to understand a bit more the challenging of living on other planets. And so join us tomorrow. Tomorrow is the last day of the public presentation. So we'll have Team Power Hub and Team Rover presenting. And in the afternoon as well, our Swiss astronaut Claude Nicollier, who will, following Sylvain's thematic about the future missions regarding the exploration of the moon. And to conclude, tomorrow is Alexander Gerst, ESA astronaut, coming to explain us his Horizons mission. And we will have a Q&A session with him. So thank you, Sylvain, for joining us today. And thank you all for watching. Bye-bye.